Hello, geometry students. Today we're going to be covering the Unit 2 packet. So have your Unit 2 open, and I'm probably going to split this into 3 separate videos, and it'll basically be the lessons, and then I'll make a separate video for the unit activity or the concept bite, whatever you want to call it. That's the graded assignment. That'll be a separate video, and then a separate video for the review. But this video is strictly on the bulk of the lessons. So here I'll be doing a lot of explaining. We'll be going over a lot of different material, basically everything that's in the bulk of the packet. So starting from the front, going all the way to the review. So if that's what you're looking for, you're in the right place. I want to remind you that everything I write down, you should be writing down. That way you'll get the fullest understanding. And also, I'm basically doing the problems that are in the packet anyway. So in order to complete your packet, you're going to need to do them anyway. All right. Let me go ahead and share my screen here. And we are going to start right here. So go ahead and go to this page right here, page 3. And we're going to cover some definitions here. Parallel lines. You've probably seen parallel lines before, but basically they're two lines that are on the same plane, but they don't touch each other. So they just go past each other like that, continuing on like that. Even if they continued forever, they would never touch each other. But it's key that they're on the same plane together. So in this case, line AE and BF, those are parallel. Here's another example of parallel lines. You can see EF and HG. See how they're on the same plane? In this case, that bottom plane of that prism, they're on the bottom plane, and those two lines would never touch each other. So those are example of parallel lines. Well, what if they don't touch each other, but they're on different planes? Well, those are what we call skew lines. So see how like AE and BC, they would not touch each other. They would just kind of go past each other. AE would go up, and then BC would go like past it, right? But they would not touch each other, but they're on different planes, right? BC is on like these two planes, AE is on like these two planes. So they're not on the same plane, they're not going the same way. So we don't call them parallel, we call them skewed lines. So what's key, notice, try to understand and see the difference between parallel lines and skewed lines. Lastly, we have one more definition to cover. It's parallel planes, which are just two planes that don't touch each other. So if you're like looking at any rectangular prism like this Kleenex box, parallel planes would be like right and left here, or front and back, or top and bottom. These planes would not cross each other, even if the plane extended forever, right? Imagine this top plane here and this bottom plane here of this prism. Even if you extended those planes out forever, they would not cross each other. So those are parallel planes. Okay, this stuff over here we're going to cover, but I'm not going to cover it in too much detail here. Kind of the main thing here is that I want you to be able to see the difference between interior and exterior. And we'll go over this in more detail just down here. So let's actually go all the way down. We're going to skip ahead to page 6. Okay, so I want you to look at this, and you can see here there are 8 total angles, and they're numbered 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 angles here, and 4 of them are considered interior, like inside. Well, which 4 angles do you think would be considered interior, inside? Well, hopefully you could see that would be angles 3, 4, 5, and 6. Do you see how they're inside? They are inside these lines M and N, right? They're inside lines M and N. So that's what we call interior angles, interior angles. So what would the other ones be called? Like 1 and 2 and 7 and 8? Well, those are exterior. They are outside that. They're outside those lines M and N. So since they're outside, we call them exterior angles. So again, 3, 4, 5, and 6 in this case are interior. They're inside, interior angles. And 1, 2, 7, and 8 are exterior angles. The last main thing here is that this line P that's cutting both those lines is called a transversal. It's called a transversal. So this line that's cutting through these other two is called a transversal. All right, now label the areas for exterior and interior. So let's go ahead and circle these, and we'll call these, I want you to label exterior, right? Exterior, as well as these 7 and 8, they're also exterior. Okay, write the full word. I don't have time to write the full word, but you do, so go ahead and do that. Meanwhile, these and these 3, 4, 5, and 6 are what? They're interior, right? So you'd write that up. Okay. Again, everything I write on the page, you should be writing on the page. Exterior, exterior, these are interior. Now, label all the pairs of alternate interior angles. I'm going to go ahead and erase what I just wrote. You don't erase, but I'm going to make it read it a little bit easier. So list all the pairs of alternate interior angles. So we're looking at interior angles. Again, that's 3, 4, 5, and 6. And we want to find the alternate interior angles. And there will be 2 pairs of alternate interior angles. So first, let's look at like angle 6 here. Angle 6. Angle 6, the alternate interior angle to that would be alternate interior. So that's on the alternate side, but also interior. So that would be angle 4. So what we're going to write here is angle 6 and angle 4. Okay, so that would be one pair of alternate interior angles. Do you see how they're on alternate sides? Basically all opposite sides, but they're both interior. Okay. What would be the other pair of alternate interior angles? So looking at the picture, what would be the other pair of alternate interior angles? See if you can figure that out. Next, we're going to look at same side interior angles. Again, we're looking at interior angles, but this time same side interior angles. Well, when they say same side, what they mean is the same side of the transversal. So on the same side of P. So same side interior angles, well, that would be angle 3 and angle 6 in this case, are same side interior. So angle 3 and angle 6 are a pair of same side interior. So same side interior angles, angle 3 and angle 6. This little symbol, right, that we're drawing looks like a less than symbol. That's like an angle symbol in this case. Okay. What would be the other pair of same side interior angles? What would be the other pair of same side interior angles? See if you can figure that out. Next, we want to list all pairs of corresponding angles. So when it says corresponding, I want you to kind of think of these intersections as rooms, right? So you have a room here and you have a room here. Okay. So angle 1 and, well, angle 1 is in like the top left position of this room. Angle 2 is in the top right position. Bottom left, bottom right. Then you'd look over here. Who's in the top right position? Well, top right position, that's angle 6. Who's in the top right position here? Well, it's angle 2. So they're in corresponding position, we would say. So angle 2 and angle 6 are an example of corresponding angles. Angle 2 and angle 6. What would be another pair of corresponding angles? 2 with 6. Well, 1 with 5. So angle 1 and angle 5. That makes another pair of corresponding angles. Oops. Angle 5. Angle 1 and angle 5 makes another pair of corresponding angles. See if you could find 2 more pairs of corresponding angles. So there should be, in total, 4 pairs of corresponding angles. See if you can write them all. Next, question 5. We're looking at alternate exterior angles. Alternate exterior angles. Well, here we're looking at, again, exterior angles. Exterior, on the outside. So we're looking at angles 1, 2, 7, and 8. What would be a pair of alternate exterior angles? Well, angle 8 with angle 2. Notice they're on alternate sides and they're exterior. So angle 8 and angle 2 are a pair of alternate exterior angles. Angle 8 with angle 2. There should be one more pair of alternate exterior angles. See if you can find the last pair of alternate exterior angles. Okay. Once you've done that, again, this should have 2 pairs in total. This one should have 2 in total. This one should have 4 in total. This one should have 2 in total. Make sure you have them all. Next, let's go on to page 7. What is a line segment that is parallel to DH? So first we need to find where DH is. Well, we can see it right here, DH. Okay, so what would be a line segment that is parallel to DH? So it needs to be going the same way as DH. That's the key. There are actually 3 possible answers we could put here. Parallel to DH would be AE. See how it's going the same way as DH? AE is going the same way as DH. What would be another parallel segment to DH? Well, CG. And then there's one more, BF. So any of those would be a correct answer. So I'm going to go ahead and put AE because AE is parallel to DH. Now, no, that kind of looks like an F. Make sure it looks like an E. Okay. Also, for line segments, I put a little segment on top. So the way you label line segments is you put both the endpoints, in this case AE, and then you put a little segment on top, indicating that that's a line segment. Would it be correct if I put EA instead? Yes, it would. Okay, as long as you put the correct endpoints and you put a little segment on top to indicate what you're talking about. So AE is the same as EA, AE, EA, same thing. Okay, again, that's not the only answer. CG would also have been acceptable, or BF. What is a line segment that is parallel to BC? So here's BC. Okay, there's BC. See if you could find a line that is parallel, or a line segment, I should say, that is parallel to segment BC. Okay, see if you can do that on your own. Next, number 8. What is a line segment that is skew to AE? So here's AE. I want to find a segment that's skewed to it. Now, if you recall, skewed means it's not touching, but they're on different planes, meaning they're not touching each other, but they're also not going the same way. Okay, so what would be an example that a segment that's skewed to that? Well, I could say GF. GF is correct. That's not the only correct answer. HG would also be correct, or DC is also correct. There's many correct answers. Just make sure it's not touching this segment. See how they're not touching each other? And also they're going different ways, right? This one's going up and down. This one's going like forward and back. So that would be an example of skewed lines. So here I could just put FG, but there's plenty of other correct answers here as well. Again, put a little segment on top. See if you could find one. See if you can find a line segment that is skewed to segment FG. Well, kind of go together. There's a hint. But you might want to write another answer. Who knows? But see if you can answer question 9. What is a plane that is parallel to plane DABC? So again, we want to find plane DABC. Let's start with that. Well, that's here, DABC. That's the top plane. Okay, so right now they're talking about the top plane for question 10. What is a plane that is parallel to the top plane? Well, that would be the bottom plane. So the plane that's parallel to DABC would be HEFG. HEFG. Okay. See if you can answer question 11 on your own. A plane that is parallel to DHGC. So DHGC, that's the back plane. See if you can find what's parallel to that. Okay, let's move on. Here's basically just connecting terms to their definitions. Okay, we've covered what these all mean before. So some of these you should know all of these, but I'll give you a few of them to just make sure get you on the right track here. Okay. I'll try to go over some of the harder ones. But again, if you need the definitions, you could go back a few pages and you could see the definitions here. Adjacent angles, alternate interior angles, parallel lines, skewed lines, parallel planes. Okay. So for example, parallel lines, let's see. Lines that are coplanar, they're on the same plane, but they do not intersect. So those are parallel lines. Oh, I put it on planes. That's not correct. Parallel lines. Lines that are coplanar and do not intersect. How about this one? Non-adjacent interior angles that lie on opposite sides of the transversal. So remember the opposite sides of the transversal, that's alternate, and they're saying interior. So these would be alternate interior angles. That's that. Okay. Okay. How about lines that are non-coplanar, so they're not on the same plane, and they are not parallel, and they don't intersect. So they're not on the same plane and they don't intersect. Well, those are skewed lines. Okay. Angles that lie on the same side of the transversal and in corresponding positions. Well, it's right there in the name. In corresponding positions. Those are corresponding angles. Okay. See if you could do the rest of these on your own. Again, you could scroll up for help or go to the previous page. It'd be scrolling up for me, but going to the previous pages where the definitions are for help. Okay. Now we're going to talk about some things that that are going to be, you're going to see a lot of. And the first thing I want to talk about is the word congruent. Congruent. You're going to see this a lot, so much in geometry. The word congruent essentially means that they have the same measure. So when you think of congruent angles, that means two angles that have the same measure. They are exactly the same measure. They're the exact same measure of openness in the case of angles. Congruent shapes are just shapes that are identical, right? So you could imagine two squares that are exactly the same or two triangles that are exactly the same. Those are what we'd call congruent. And the way we measure angles has to do with how open they are. So when I draw an angle like this, and then perhaps another angle like this, and then another angle like this, hopefully you'll be able to identify that this first angle I drew has the lowest measure, right? It's not very open. Whereas this second angle is open more, right? So this one's more open. So this one would have a greater measure in terms of degrees. So this one might be 25 degrees. This one's I try to draw 90 degrees. And then this one is open even more than 90, right? So if this is 90, this one's open more than that. So this one would have a measure that is greater than 90, perhaps 130 or something like that. Okay. And So hopefully you can, and even if I don't know the exact measure of this angle, I could at least see with my eyes that this angle is definitely has a lower measure than this angle, and this one definitely has a lower measure than this one, because this one's least open, this one is open more than that, but this one's open the most. Okay, and again, measuring angles is a measure of how open that angle is. And again, congruent means that two things have the same measure. So I might draw two angles like this. So these two angles, I try to draw them with the same measure. But if they have the same degrees, like if this one's 28 degrees and this one's also 28 degrees, then we can say that these two angles are congruent. Okay? They don't have to be facing the same way or anything like that. But you can see these two angles, if they have the same measure, we call them congruent. Now, what's the symbol for congruent? It looks like an equals with a little squiggle on top. Okay? An equals with a little squiggle on top, that means congruent. So the way you would read, for example, this statement here, you would read that as angle 2 is congruent to angle 8. All right? I know it's a lot of words, not very many symbols, right? In math, we try to condense words into symbols, but that's what these symbols mean together. It means angle 2 is congruent to angle 8, or here, angle 3 is congruent to angle 5. We're going to use this idea of congruence. We're going to use this symbol a lot. We're going to use the idea of congruence a lot. Here I could say that these two angles are congruent. Okay. Now, let's go down here, and we're going to talk about congruence with a bunch of different angles here. Now, this looks like something we worked with before. Remember, we worked with like the alternate interior angles, alternate exterior angles, corresponding angles. Well, that's going to work here as well. What we're trying to find in this example, it says, in the image, identify all the angles that are congruent to angle 3 and give a reason that you know. So the first part is, what are all the angles that are congruent to angle 3? So here's angle 3. And I'm looking for angles that have the same measure as that. In other words, they're open the same amount as angle 3. Try to draw that as an arc. So looking at this picture, do we see any angles that are open the same amount as angle 3? Angle 3 is, if I look at like angle 2, I would say these are not congruent. You can kind of see that already, right? Angle 3 is more open than angle 2. So these are definitely not congruent. Well, what about angle 1? Yeah, these seem to be open the same amount. Yeah, these will be congruent. So angle 1 and angle 3 are going to be congruent. What about over here? Do we see any angles that are open the same amount as angle 3? Well, you could see angle 7 and angle 3. These are clearly open the same amount, right? These corresponding angles here, these are open the same amount. So those are going to be congruent. And also angle 5. Okay. So kind of the key thing here is that when you have these two lines parallel, in this case, M and N are parallel, and they're cut by a transversal. In this case, the transversal is T. It creates a lot of congruent angles, a lot of angles that have the same measure. In this case, angle 3 is going to be congruent to angle 1. Angle 3 is also congruent to angle 7. And angle 3 is also congruent to angle 5 in this case. Now, what are the reasons? Well, for the reasoning, right, because it says give the reason you know for each one. So the reasoning has to do with the relationship to angle 3. So what's the relationship between angle 3 and angle 5 in this case? Well, I hope you can see that these are alternate interior angles. So angle 3 is congruent to angle 5 because they are alternate interior angles. Okay, so basically we're just putting what it's congruent to and how we know. What's the relationship between that angle and the other? Alternate interior angles, by the way, when you have parallel lines, alternate interior angles are always congruent when you have parallel lines. This will come into play a lot. So I know this might seem like a lot right now, but it'll be important to know. So pay close attention here. That's why I'm taking a lot of time here. Angle 3 is congruent to angle 7. Okay, well, what's their relationship? Well, they're corresponding angles, aren't they? Right, they're in corresponding positions. Angle 3 is in the same position as angle 7. They are corresponding positions. So angle 3 is congruent to angle 7 because of corresponding angles. They are corresponding angles. And angle 3 is congruent to angle 1 because of vertical angles. Now, I know we haven't covered that yet, so I'm going to talk about that a bit. Whenever you have two lines crossing each other, and it doesn't matter how the lines are in any way, as long as they're crossing each other, the opposite angles will be congruent to each other. So like this will be congruent to this, and the top angle here will be congruent to the bottom angle, okay? And what we call there is vertical angles, okay? So the left and right angles in this case are congruent because they are vertical angles, and the top and bottom angles are congruent as well because of vertical angles. So you can see the two lines crossing, M and T are crossing, and that means angle 3 will be congruent to angle 1 because they are vertical angles. Okay. You can see there's plenty of other pairs of vertical angles in this picture, right? 4 and 2 are congruent to each other because of vertical angles. 6 and 8, 7 and 5. Okay. All right. I hope that makes sense. Hope that makes sense. And you can see up here in the definitions, it talks more about that, right? Vertical angles here, opposite angles of intersecting lines. So in this case, 1 and 3 and 4 and 2. Okay. Now, I'm going to go ahead and erase these things that I've drawn here. Okay. Now, in question 1, in the image above, identify all the angles that are congruent to angle 8 and give the reason. So it's just like what we did, what this example shows with angle 3. But this time, we're going to be looking at angle 8. So angle 8 here. Angle 8 is going to be congruent to, so it's important that we write all the symbols correctly. So angle 8 is congruent to angle, well, it's congruent to angle 6 for sure, right? Why? Because they are vertical angles. Because they are vertical angles. All right. Because they are vertical angles. They are vertical angles. It takes a while to write with a mouse. I hope you can read that. All right. So angle 8 is congruent to angle 6 because they are vertical angles. All right. Well, angle 8 is also congruent to what other angles? Well, let's see. Well, I'm looking for ones that are the same openness as angle 8. Oh, we could see angle 4. See, angle 4 and 8 are the same, and also angle 2. Okay. Notice 2, 4, 6, and 8. These are all congruent to each other, right? They're all congruent to each other. They're all the same measure. As well as 1, 3, 5, and 7 are all congruent to each other. So anyway, angle 8 is congruent to angle 4 because why? Angle 8 is congruent to angle 4 because they are corresponding angles. So because they are corresponding angles. I want you to write that out. So angle 8 is congruent to angle 4 because they are corresponding angles, just like up here. And finally, angle 8 is congruent to angle 2 because, well, what's their relationship? In this one, they said alternate interior for a 3 and 5. But are 8 and 2, are they interior? No, 8 and 2 are exterior angles. So we would say angle 8 is congruent to angle 2 because they are alternate exterior angles, right? 8 and 2 in this case are alternate exterior angles. Make sure you write those because da da da. So here, For the angle 8 is congruent to angle 4 because they're corresponding angles. Angle 8 is congruent to angle 2 because they're alternate exterior angles. Okay. Now we got to talk about something else. So I know I'm going over a lot of material here, but just bear with me. In the image above, identify all angles that are supplementary to angle 5 and give the reason that you know. Use definitions on the previous page for help. Okay, so here we're going to talk about supplementary angles. Now, what does that mean? Supplementary. So now we're not talking about congruent angles. We're talking about supplementary angles. Well, if we go up here, we can see the definition. Supplementary angles are two angles whose sum is equal to 180. All right. Basically, any two angles that add up to 180, or their measures add up to 180, they are supplementary. Okay, so supplementary angles, their angles add up to 180. When you have two angles on a straight line like that, they will always be supplementary. They will always be supplementary because a straight line is 180 degrees. So when you have two angles on a straight line like that, they will always be supplementary because they form a straight line, which is 180 degrees. So we might see that a lot in this picture, right? So in here, we're looking for supplementary to angle 5. So here's angle 5. What would be an angle that is supplementary to that? Well, we can look for a linear pair, meaning they're on the same line together, like that, forming a straight line. Well, angle 5 forms a straight line with angle 6. Oh, so that means angle 5 must be supplementary to angle 6. Angle 5 is supplementary, not congruent. We're not working with congruent anymore. Is supplementary to angle 6. And how do we know that? Because they are a linear pair. Because they are a linear pair. A linear pair. Okay. Angle 5 is supplementary to angle 6 because they are a linear pair. My writing is not good on this mouse, but that's okay. Hopefully that makes sense. Is angle 5 a linear pair with another angle? Well, yes. Angle 5 is a linear pair with angle 8. Okay, so let's go and write that as well. Angle 5 is supplementary. It's a 5 there. Angle 5 is supplementary to angle 8. Again, because 5 and 8 form a linear pair, right? See how they form that straight line together? They're on that straight line together. So angle 5 is supplementary to angle 8 as well. So it's supplementary to angle 6, and it's supplementary to angle 8 for the same reason, because 5 and 6 are a linear pair, and 5 and 8 are also another different linear pair. Okay. Lastly, angle 5 is also supplementary to angle 4. Okay. This one has a different reason. This would not be a linear pair in this case. So last one, angle 5 is supplementary to angle 4. Make sure you write that in. I'm not going to bother, but you know what I mean. Same deal. Angle 5 is supplementary to angle 4. How do we know that? Well, there's another relationship we need to talk about. Same side interior angles. So when you have same side interior angles, those are going to be supplementary. So 4 and 5 in this case are supplementary because they are same side interior angles. Okay. So whenever you see same side interior angles, those are supplementary. Alternate interior angles, alternate interior like 5 and 3, those are congruent. But same side interior angles, same side, see on the same side of T here, those are supplementary. They would add up to 180. They're supplementary. Okay. Now, let's go on to the next page, page 11. I know this looks complicated. There's a lot of stuff going on, right? There's like, oh, statement. There's a lot of symbols here, right? Some of these we know, some of these we might not know. By the way, when you see these two lines together like that, like it says M and it has two lines and then N, that means parallel to. So you'd read that as line M is parallel to line N. Okay? And over here we have reasons for all this stuff. But I want you to focus on, let's just figure out what goes in this blank here. What's this reason? So 5 and 8 are supplementary. So here's 5 and 8. It says they are supplementary. And over here for the reason, we need to write why we know that's true. How do we know that 5 and 8 are supplementary? Well, just like up here, 5 and 8 were supplementary. Why? Because they were a linear pair. Same thing. These form that straight line together. So how do we know 5 and 8 are supplementary? Because they are a linear pair. Linear pair. And that's it. You're done. Okay? Let's move on. Here, angle 1 is congruent to angle 5. How do we know that's true? Let's look at our picture. Angle 1 and angle 5. Well, what's their relationship? What's the relationship between angle 1 and angle 5? Well, they're in corresponding positions. They are corresponding angles. So how do we know angle 1 is congruent to angle 5? Because they are corresponding angles. Corresponding angles. Okay. Great. Cool. Move on. Page 12. So here's where we're going to talk about, we're going to work with some measurements here. So you can see there's a bunch of lines here. There's lines A and B, and it shows that A and B are parallel to each other. M and N are also parallel. So you have 4 lines, M and N are parallel to each other, A and B are parallel to each other, and they're crossing. Here it says the measure of angle 5 is 120 degrees because of corresponding angles. Okay. Well, here they give you one measure. They give you this measure right here, 120 degrees. Nothing else in this picture is a measurement, right? These are just angle names. Like this one's named angle 1, angle 2, angle 3, angle 4, so on. But this one has a degrees on it. So this one's a measurement. So this one's saying that this angle right here, specifically this angle right here, measures 120 degrees. Okay. So based on that, if this is 120 degrees, what would be the measure of angle 5? Well, that would also be 120. Okay. That reason we know is because they're in corresponding positions. They are both congruent to each other because they're corresponding angles. Okay. So measure of angle 5 equals 120 degrees because of corresponding angles. By the way, whenever you see M angle something, that means the measure of angle 5. So whenever you see M angle something, they're telling you the measurement. So the measure of angle 5 is 120 degrees in this case. What is the measure of angle 12 and which theorem justifies that answer? So I'm going to write the measure of angle 12 equals, let's look. Where's angle 12? Here it is. Okay. Now the only angle we know the measurement is this 120 degrees right here. Well, what's the relationship there with angle 12? Well, looks like they're same side interior, right? Same side interior. So same side interior, these are going to be supplementary to each other, supplementary. So the measure of angle 12 will be 60 degrees. How do I know that? Because these two angles need to add up to 180. Angle, this 120 and this angle 12 need to add up to 180 in order to be supplementary. So how do we know that this is 60 degrees? I want you to write because they are same side interior angles. same side interior angles. So I'm gonna help you with some of this, but I want you to write the explanation, okay? Because same side interior angles. So the 120 degrees with the 12, measure of angle 12 is 60 degrees because same side interior angles. What is the measure of angle 7? The measure of angle 7 equals, so the measure of angle 7, well, again, we're going to relate it to this 120. So here's angle 7 here. What was the relationship there? Well, they're on alternate sides. They certainly look congruent, right? They're open the same amount. You can see they're open the same amount. Yeah, so that's 120 degrees. Okay, well, what's the reasoning? Well, you see they're on alternate sides and they're inside lines A and B, right? They're inside these, so they're alternate interior angles, alternate interior angles. Okay. Measure of angle 16. Oop, I don't want a comma. Equals. So here's angle 16. Well, these two angles form a linear pair, right? They're on that straight line together. They form a straight line. So they're a linear pair. Okay, so what does that mean? Well, it means they're supplementary. So this must also be 60. Right? Because a linear pair, they're always supplementary, meaning they add up to 180. So how do we know it equals 60 degrees? Because it forms a linear pair with the 120. Okay, because a linear pair. What's the measure of angle 15? The measure of angle 15 equals, so here's angle 15 here. How does that relate to the 120 here? I hope you can see that those would form vertical angles, And you can see they're open the same amount and they're congruent to each other, right? So this one would also equal 120 degrees. Why? Because it's vertical angles. So here you'd write vertical angles because of vertical angles. Now, one thing I want to point out is that every single angle in this picture is either 120 degrees or it's 60. So all these will be the same measure, either 120 degrees or 60 degrees, depending on whether it's, you could see some of them are more open than others. Like I'm going to go ahead and highlight all the ones with 120. That would be this one, this one. See how they're both open the same amount? You can see 9 is corresponding to the 120. This 11 is corresponding to the 15. This and this, this and this. So these would all be 120 degrees. These are all congruent to each other. Meanwhile, all the other ones would be 60. Okay. For this page, page 13, 14, and 15, I'm going to cover that in another video. It'll be a shorter video, but I'm going to cover that in another video. And so if you want to do those, you'll go ahead and go to that other video. Okay. All right. Let's go ahead and go on to page 17. Okay. Here's an example. Identify which lines are parallel if angle 1 is congruent to angle 2. Justify your answer. So this time, instead of pointing out whether or not the angles are congruent or supplementary, here we're trying to figure out which lines are parallel. So the first thing we would do, what I would do is I would look at these two angles, find them on my picture. So angle 1 and angle 2. So we got angle 1 and angle 2. Okay. Now, I would look at which lines are involved with these angles. So which lines are involved with angle 1 and angle 2? Well, we could see line N for sure, right? See how that touches angle 1 and angle 2? And then lines A and B, right? A for angle 1 and B for angle 2. So you see the lines that are involved are A, B, and N. N is the transversal in this case. So M is not involved at all. M is not involved at all. So looking at this picture, the lines that are involved are A, B, and N. If I'm looking at those three lines, the ones that are involved, which of those lines are parallel to each other, right? Because we're saying which lines are parallel. Would A be parallel to N? No, that doesn't make sense. B to N? No. A and B are parallel. Ah, yes. So here we would write lines A and B are parallel to each other. Okay, cool. Now, how do we know that? Well, for that, we want to look at the relationship between angle 1 and angle 2. So what's the relationship between angle 1 and angle 2? Are they alternate interior angles? Are they alternate exterior angles? Are they same side interior? No, these are corresponding angles, right? You see how they're in corresponding position? So whenever we're showing that lines are parallel, we actually have to use what's called the converse. So you're going to write, in this case, A and B are parallel to each other because of converse of corresponding angles, right? They're corresponding angles. And anytime we show lines are parallel, we're going to be using the converse. So there's many converse here. So you got the converse of same side interior, converse of alternate interior, converse of corresponding angles, and converse of alternate exterior angles. All of these basically serve the same purpose. So it's nothing really new you need to learn. It's just that whenever you're showing the lines are parallel, so anytime you say, oh, these lines are parallel because you're going to be using one of these converse ones. You're going to be using converse of same side interior or converse of alternate exterior, one of these converses. Okay? And the relationships between the angles are the same you've already learned. So these are corresponding. So A and B are parallel because of converse of corresponding angles. You can see these are in corresponding position. All right. So just make sure you're putting that converse there. So identify which lines are parallel if angle 2 is congruent to angle 6. So let's find our angles. So we have angle 2 and angle 6. Okay. Well, which lines are involved here? So N is involved with angle 2, M is involved with angle 6, and then B is involved with both the angles. So A is not involved at all with these angles. So of those three that I just highlighted, which lines are parallel? Well, M and N are parallel. So we would say line M is parallel to line N. And again, when you see those two lines together like that, that means they're parallel. So M is parallel to line N, comma, because why? Because, now make sure you say converse. So anytime you're showing lines are parallel, converse of, in this case, what's their relationship? Well, these are alternate interior angles. Hopefully you can see that. These are alternate interior angles. They're on the interior of lines M and N, and they're alternate sides. So converse of alternate interior angles. Alternate interior angles. Okay, I know I'm using a lot of shorthand here, but you're welcome to use shorthand if you want, or you could write it all out, complete sentence in English. Okay. Notice all of these questions say identify which lines are parallel. So all of them will kind of be in this form where it'll be this line's parallel to that line because, and they'll all have converse of something. So it'll be converse of, you're going to be using one of these four for all of these. So it'll be because of, converse of, and the one we just did was alternate interior angles, but it could be any of these. You just got to find the relationship. That's correct. So in this one, identify which lines are parallel if the measure of angle 5 plus the measure of angle 6 equals 180 degrees. Basically, they're saying measure of angle 5 and 6 are supplementary. So let's go ahead and find our angles, angle 5 and angle 6. Well, which lines are involved here? Well, M is involved because it's touching both the angles. A is involved because it's touching angle 5, and B is involved because it's touching angle 6. Okay, so which lines are parallel? A and B in this case. So A is parallel to B, comma, because why? Because converse of, well, let's see what's their relationship here. Well, they're interior. Are they on alternate sides of M, or are they on the same side as M? Well, they're on the same side as M. So these are same side interior angles, same side interior. So A is parallel to B because converse of same side interior angles. Make sure you write that all out. A is parallel to B because converse of same side interior angles. All right, next one. Everything I write, you write, as well as everything that I say you need to write. You need to write, okay? Angle 3 is congruent to angle 8. So angle 3 and angle 8. Well, which lines are involved here? Well, A is involved, clearly. M is involved with angle 3, and N is involved with angle 8. So when I look at this, out of the 3 lines involved, which ones are parallel? M and N again, right? So M is parallel to N because why? Because converse of, well, what's their relationship here? Are they interior or exterior? Well, this time they're exterior, and they're alternate exterior. So because converse of alternate exterior angles. Okay. All right, so I've given you 3 examples, and you have this example here. See if you can do 4 and 5 on your own. See if you can do 4 and 5 on your own. Good luck. Let's look at angle 6. It's not much different. Here it says, in the picture below, if angle 1 is congruent to angle 2, are lines R and S parallel? Explain your reasoning. So angle 1 and angle 2 are congruent. So this is congruent to this. Okay, so yes, S is parallel to R. Why? Well, whenever we're showing lines of parallel, it's got to be because of converse of something, right? So S is parallel to R because converse of, and this in this example, alternate interior angles. So because of converse of alternate interior angles. Remember, whenever you're showing lines of parallel, you're going to be using converse of something. And the relationship in this case is they are alternate interior angles. Okay. Next, we're going to do a little bit algebra with these two problems here. Here, it says, what must the value of x be if m is parallel to n? So m and n are parallel. We want to find the value of x. So in this case, with these 2 values, in this case, they are alternate interior angles. See how they're alternate interior? Well, alternate interior angles are congruent. So that means these are congruent to each other. So 2x plus 30, 2x plus 30 will equal 60 because they are congruent to each other. So when you see that the relationship between these 2 angles is that they're congruent to each other, we would just put these 2 things equal to each other and solve for x. So hopefully you remember from algebra how to solve for x here. My first step, I think, would be to subtract 30 both sides. Subtract 30 both sides of the equation. This cancels the 30 over here, leaving me with just 2x on the left. On the right, 60 minus 30, well, that gives me 30. 60 minus 30. Now to get rid of this 2 and get x by itself, we go ahead and divide by 2. That'll give me, with these 2's canceled, x equals 30 divided by 2, 15. Cool. So again, these are congruent, so just put them equal to each other. In this case, here, we have 50 here and 2x plus 30 here. In this one's case, are these congruent? Well, yes, they are alternate exterior angles. So alternate exterior angles are congruent. So we would put 2x plus 30 equals, and in this case, 50. Go ahead and solve for x here. Follow the example from this one if you're not sure what to do. Now we're going to talk a little bit about triangles. And the main thing I want you to understand with triangles and the angles inside is that if you take the measure of the three angles inside the triangle, they will add up to 180. And that's true no matter what triangle. So any triangle you'll ever see, or any triangle you ever have seen, the three angles inside, the three interior angles, the inside angles, they always add up to 180. Always. Okay? So that means if I know two of the angles, I can figure out the third angle because the three angles together I know must add up to 180. So they show an example of that. Like if we know that this angle is 82 degrees and we know that this angle is 65 degrees, we can find the measure of the third angle because I know the three angles together must add up to 180. And you can see the equation they set up is that these two values plus x, so 65 plus 82 plus x, they add up to 180. You can see that here, 65 plus 82 plus x, they add up to 180. Combining like terms, the 65 and 82 gives you that. Subtract 147 both sides, and you get that x equals 33. And you could always double check because remember, the three angles together should add to 180. So you could always check that answer. Add the three angles together, they should add to 180. And in this case, they do. So you know it's correct. Okay. What if we got something funky like this? So we've got a big triangle, and that big triangle is cut into two smaller triangles, and there's some angles they give us, but you can see there's three things we don't know. We don't know x, y, and z. Can we find all of these? Well, yes, we can in this case. We could find x because these three angles need to add to 180, right? Just looking at this left triangle, I know that these three angles have to add to 180. So therefore, I could find x. In this case, x would be 100. I'm not showing all the work, but we will later with some of the examples do a bunch of the work, but I just want to show you the idea. Okay, so we know that this has to be 100 because they have to add up to 180. Okay, and these two together add up to 80, so I know this one must be 100. What about angle y? Well, angle y is easy because look, do you see how these are on a straight line together? X and y are on a straight line together. Well, that means that they're a linear pair. Do you remember a linear pair? That means two angles that form a straight line. In this case, this one's 100. So this one must be 80 because they're on a straight line together. And remember, two angles on a straight line together that form a straight line are always supplementary, meaning they always add up to 180. Well, now that I know, now looking at this right triangle, I can see this one's 65, this one's 80. Well, what's z? Well, I know the three angles together must add up to 180. And these two together add up to 145. So that means this one must be 35. Because the three angles together must add up to 180. Okay, there you go. You found x because these add to 180. Found y because these must add up to 180. And then we found z because these three angles must add up to 180. Okay, it's kind of like a puzzle. See what pieces you can find easily and then work with those new pieces to see if you can find more. Right? Here they showed kind of the same thing. We know 38 and 42, so we can find x. X is 100. 100 and y form a linear pair, so that means this one must be 80. And 65 and 80, so we could find z is 35. Based on that example, let's see if you can let's see if we can work this one out here. Okay, got my calculator over here. Let's go ahead and find x. Okay, so I know that these three angles on the left triangle must add up to 180. So we got 59 plus 43 plus x equals 180. 59 plus 43, 102 plus x equals 180. Subtract 102 from both sides gives you that x equals 78. Just like that, we found x. 78. X and y form a linear pair. So that means x and y must add up to 180. So 78 plus y must equal 180. Oh, that gives you that y automatically is 102, what we found over here. Right? Because I know these must have 180. So this one must be 102. Well, what about this triangle over here? See if you could find the measure of angle z. So see if you can find the measure of angle z using the information in this triangle. Remember, in this triangle, they must add up to 180. And you could always check your work too. Once you're done with that, see if you could try number 2 here. Here you should be able to find z easily enough because the three angles add up to 180. This 103 and x are a linear pair, so they must add up to 180. And then once you have x, see if you can find y. You may have to pause the video and work that out. All right. Next page. What is the value of x here? Well, there is a property that basically says if you have an exterior angle, an outside angle from a triangle, you could add the two interior angles that are far away, and these will always add up to this exterior angle. But I think that's a little bit hard to remember, right? Like what if I gave you this angle instead? It might be hard to remember which ones to add or how that works. What I like to do is you don't have to learn anything new. It's basically what we've already done in the previous problems up here. Here, let's go ahead and find this angle first. Find this angle. I know it's not labeled or anything, but we can find this angle measure. Well, how do we do that? Well, the three angles in here have to add up to 180. So let's go ahead and add up these two together. 108 plus 32. Those add up to 140. So what would this one have to be? Well, this one would have to be 40. How do I know? Because the three angles have to add up to 180. The three angles on the inside of the triangle have to add up to 180. Well, now these two, 40 and the x, form a linear pair. So that means that this one must be 140. And you're done. Okay. Show some of that work here, and that's it. Can we do something similar for this one? Well, yes. This 156 and this angle here add up to 180 because they're a linear pair. So 180 minus 156 will give me that. Okay, it's 24. Now, look inside this triangle. The three angles together in this triangle should add to 180. So see if you can figure out x from there. The three angles inside should add to 180. And again, you could always check your work to make sure they do indeed add to 180. Number 5 is exactly like number 4, just with different numbers. So see if you can do the rest of number 4 and see if you can do number 5 on your own. Next, we're going to talk a little bit about parallelograms. A parallelogram is a four-sided shape with the opposite sides are parallel. So the top and bottom in this case are parallel to each other. Top and bottom are parallel, and the left and right are parallel. So that forms a parallelogram. Okay. Let's go down to these problems here. I just want you to find the measure of the angles. Okay. Now, what's key here is that the opposite angles are congruent to each other. So, for example, angle A is congruent to angle C. And you can see they're open the same amount, aren't they? So we know that those two angles, they look congruent, and indeed they are. Okay. Opposite angles in a parallelogram are always congruent. Similarly, angle B and angle D are congruent to each other. Well, what about A and D? Are they congruent to each other? Well, clearly not. See how D is open a lot less than A? A is open a lot more, right? They're not congruent to each other, but they are supplementary. So if this one's 110 degrees, angle D is supplementary to that. So that one would be 70 degrees. Notice they add to 180. So if it says right here for question 2, if the measure of angle A is 110, what is the measure of angle D? The measure of angle D in this case, if A is 110, then the measure of angle D equals 70 degrees. Okay, pretty simple. The opposite angles are congruent, but if they're next to each other, they're not congruent. In fact, they are supplementary. If the measure of angle A is 110, what is the measure of angle B? So if this is 110, what do you suppose the measure of angle B is? See if you can answer that. If the measure of angle D is 76, lastly, question 3. If the measure of angle D is 76, what is the measure of angle B? Well, opposite angles are congruent, right? So that therefore they have the same measure. So if angle D is 76, then the measure of angle B would also be 76 degrees. Okay. Again, because they're opposite angles. Okay, we're almost done. Just a couple more pages. Let's take a look at this next one. Here, what you kind of want to know here is that when you connect the opposites of a parallelogram, then those lines that you created actually cut each other in half. You actually cut each other in half. So, for example, that would mean that x in this case is the same length as y minus 3. Or in other words, AQ is the same as CQ. AQ will be congruent to CQ. Similarly, BQ would be congruent to DQ. Okay. So how can we use that information to help us solve something like this? Well, let's see. We know that AQ will be congruent to CQ. So AQ, which is x, will be congruent to CQ, which is y minus 2. Okay, that's one equation. The other equation we can get from DQ is congruent to BQ. So that means that 2x plus 10 DQ will be equal to BQ, which is y plus 14. Okay, hope that makes sense how I've gotten these two equations. Now we're going to be doing some algebra. So maybe I could change my color here. So see how it says x equals y minus 2? So since it says x is y minus 2, I could substitute that in for x over here. Okay. In algebra, we call this the substitution property. Okay, when you see that x equals something, you could replace that x in another equation with that something. So we would replace this with, instead of 2 times x, it'll become 2 times y minus 2. So this would be 2, and we're going to replace the x with y minus 2. Substituting it. The rest of the equation remains the same. Plus 10 equals y plus 14. Now you may be thinking, well, why would you want to do that? Because now we just made it more complicated looking. But basically what we've done is we've created a new equation that only has y in it. And because it only has y in it, we could solve for y. So the next thing I would do, hopefully you would see that I would distribute the 2 here. So 2 times y and 2 times minus 2. So 2 times y is 2y. 2 times minus 2 is minus 4. Then there's a plus 10 over here. There's a y plus 14 on the right side. Combine like terms on the left, the minus 4 and the plus 10, those combine to make plus 6, right? Negative 4 plus 10 is 6. Okay. The next thing I would want to do is, you see how there's y's on both sides? I don't really like that. So I'm going to go ahead and subtract y over here and subtract y over here. That way I can cancel the y on the right, and I'll only have y's on the left. So 2y minus a y is y. Here we still have a plus 6 on the left, and then we have a 14 on the right. Do you see what the last step would be in this case? The last step would be to get y by itself, subtract 6. So we're going to go and subtract 6 both sides. So that'll give us that y equals 14 minus 6 is 8. So that gives you the y. Now once we have y, we could plug it back into one of the original equations to find x. Let's plug it into this equation here. So this x equals y minus 2 becomes x equals, and we're going to replace the y with what it equals. So x equals y becomes x equals 8 minus 2, which gives you that x equals 6. 8 minus 2, that's 6. So then you're done. So you got the y coordinate, you got the x, and you're done. Okay, I know that one's complicated, but that's how it's done. I hope that at least sort of made sense. Okay, these last two are actually quite easy, and it'll make complete sense once you see it. So it says in the figure, AF is parallel to BE is parallel to CD. Okay, so we have 3 parallel lines, that's what it's saying. So AF is parallel to BE is parallel to CD. And then it says FE equals ED equals 4. So basically all it's saying is these both equal 4. And you can see there's 4s there to show that. And then it says AB equals 2.8. So the distance from A to B equals 2.8. Now it's asking, what is the distance from A to C? So it's asking, what is AC? So that's the distance from A to C. Well, we can already see the distance from A to B. The distance from A to B is 2.8. What will be the distance from B to C? Well, that'll be the same. Also 2.8. Right, so distance from A to B is 2.8. The distance from B to C is 2.8. So now what would be the distance from A to C? Well, that would just be 2.8 plus another 2.8. The AB plus BC. So that total distance would be 5.6. So we'd write AC equals 5.6. So the distance from A to C is 5.6. This one's similar. Notice these are all 5s, 5, 5, 5. So that means these will all be the same as well. 4, 4, 4. So if these are all the same, then these will all be the same, as long as these are parallel across. Then it asks, what's the distance from E to H? So from E to H, what's that distance? Well, that would be 4 plus 4 plus 4. Well, that's 12. Okay. After that is the review. So that means we've covered every lesson in the unit. All right. And I hope that made sense. I hope that was clear. Good luck. I'm going to go over the review in a separate video, as well as go over that graded assignment, the concept in a separate video as well. So be on the lookout. Those should be on the Google Classroom as well. So you can go ahead and do those whenever you're ready. And I hope that made sense, and I hope you're able to do the problems I asked you to do on your own. All right. So good luck, and thank you for your attention. See you next time.